First of all, thank you for having me today and given the possibility to present my research project. And thanks for the audience who's still here on a Saturday afternoon. So I've done my research project on leptospirosis, and it's a prevalence study. And as you can see, it's been done in Australia, in Victoria, which is the little red area you can see in the Australian map. And we also wanted to see how vaccinations are going. So there will be I will go for an introduction, material, methods, results, and then the discussion. Now, why are we looking at this? There hasn't been actually a prevalence study been done for the last good 30 years in Victoria. And back then, the serology showed that there was quite widespread. Obviously, lepto is a risk for humans, it's a zoonosis, and even at that time, when they investigated into farm workers, farmers, they realised that it was quite seroprevalent in workers and farmers too. Now, looking back, this is actually showing human cases between 1996 and up to now. And as you can see, it's quite amazing. Years ago, lepto, these days we know lepto is still prevalent, especially in Queensland, in Australia, but mainly with banana pickers and things like this. But back then, Victoria was actually the winner, and we had the most lepto cases, and it was all associated with farming. So over the years, as you can see, the prevalence has actually come down quite a bit. Now, at the time where I investigated, which was 2016 and 2017 when I sampled, I actually, hang on, the area that I was sampling, which I don't know why, is this area where we investigated, so it's southwest Victoria. And as you can see, there were human cases in 2016, and there were also human cases in 2017. And this shows that it's still cases in humans at those periods. Now, the aim of this study, as I said before, is to look at the prevalence of mainly Leptospira, borgpetersenii, Hardjo, and Leptospira interrogans, Pomona, as those were the main serovars found back then. The reason why we also wanted to see how vaccination programs are working, because obviously we've seen there has been a decline in human cases, and the question is this because it's not there anymore? Have we done a really good job, or are we just not picking up on it? So this was a pilot study, a cross-sectional study. I ended up having 53 participants who were all local farms. We applied a survey to the farmers or farm workers and also sampled 15 cows per herd. Now, we did let the farm workers or farmers choose the cows. Only requirements were that they had to have had fertility problems, because previous studies did show that there is a correlation between there can be between fertility issues and leptospirosis, and also vaccination trials have shown that they can improve fertility in herds. But all these studies have been back in the UK, so there is not actually any proof at the moment with Australian studies, but we decided to still try to focus on cows that possibly give us more positives, to see if we can find cases. And the other reason we didn't look for ages or anything was because we really just wanted to... farmers are exposed when they're milking, and there's all types of cows, all types of ages. So we really just wanted, the only criteria was they had to have some fertility issues. Now, we've injected these cows also with some furosemide, and then tried to collect the second voiding. If you can see this down here, this is actually urine of the second voiding, so it becomes really, really watery and it doesn't look like urine anymore. The reason for this is that there has been a study done which actually showed if we use furosemide, the second voiding can be up to 50% more likely to harbour Leptospira if it's present in the kidneys. And this is the area where we sampled. So it's actually, we got quite a nice spread out in southwest Victoria. Over here, that's actually Melbourne, and back here we'd be going towards South Australia. So, yeah. Now, the samples, that's materials and methods, sorry, the samples of each herd then were pooled. So we didn't just do single samples. And once the pooled samples were done, we did test single herd samples. And once that was done, if we identified positive herds, we did a serovirus-specific PCR for both Hardjo and Pomona. On top of this, we did try to, well, we didn't try, we actually developed a wetness index. So a wetness index is basically giving you ideas of how much water accumulates in certain areas, and that's by slopes and water catchment. And so we tried to find out and correlate how wet were the herds where we sampled, and was there a correlation between positive and negative herds. So coming to the results, we did have 3 of 54 herds that came back positive in the pooled samples. Now, when I say it came back positive in the pooled samples, the really interesting thing is that all our pools, when we then did the final sampling, were at least 3 positive cows. So we had 3 to 5 positive cows plus inconclusive in the single sampling. And then when we did finally do all the rest of the single sampling, we only identified 1 more herd, which actually had a weak positive and an inconclusive. And then, as I said, those herds that came back positive, we did do serovirus-specific PCR. Now, this comes to a prevalence of 8%, so 4 of our 53 herds came back as leptopositive. Out of those 4 herds that we identified, there was 2 herds that basically vaccinated everything, but they didn't do it completely compliant to the label, and 2 of the other herds were only partly vaccinated. I'll go into a bit more detail in a minute. And out of the samples that we sampled, we actually found that 71% of the samples came back as Hardjo, which is slightly different to, I think, newer studies in New Zealand, as we heard yesterday. So the survey, as I said, we had 36 herds out of 52 didn't vaccinate correctly, which gives us actually a prevalence of 69 herds that weren't compliantly vaccinated. I put down this in a bit more detail. So in total, I just had 1 herd that did not vaccinate at all. When I'm saying non-compliantly fully vaccinated, I'm talking about herds that vaccinate all age groups. They start with the calves, but they have a flaw in their vaccination. So I've identified herds that would vaccinate with an interval between first and the second vaccine, like up to 3 to 5 months. Or they would vaccinate the herds under 12 weeks old and wouldn't give them the 3rd vaccination. And then the compliant vaccinated are directly to the label directions, and partly vaccinated. In this case, we just found herds that were vaccinating only the calves but weren't vaccinating the cows, which is still quite a high percentage of farmers who are basically vaccinating their cattle incorrectly. Now, obviously it was a pilot study, so looking and trying to look at risk factors, we looked at, what were they vaccinating, did they have other livestock around, like pigs, what was their quarantines and things like this. Everything was unfortunately not significant, but then we found, while we did the survey, farmers were quite willing to tell us, someone in the family or someone on the farm had lepto, and we actually found that there was a 12.9 times more likeliness of human cases on previous farms, on cases of lepto, if there was human cases in previous farms. Now, when I'm saying human cases on these farms, those cases have happened in the last 30 years, so they reached from 1983 up to 2007, so they've actually been quite a few years back. They've not been recent cases at all. And so this brings me then to the wetness index that I was talking about before. I hope you can see this. So we have the clear herds, which are the green spots, and then we have the herds that came back positive, which is one in the middle there. But then the other three are just here, here, and here, just there, yeah, in the back. And as you can see, with this wetness index, so the lighter the blue, the less wet, and obviously the darker the blue, the wetter. And interestingly, my 3 cases are all going towards the wetter areas, which would agree with lepto, who's obviously a disease that will survive and gets shed by the urine, but then also can be survival quite better in stagnant waters and things like this. Now, which brings me again to this point. So we did correlate the wetness index with the lepto cases, or the lepto farms, and interestingly, the wettest farm was actually one of my positives, which is a nice thing to see. And the other farms, as you can see, there was slight correlation, but it was just 4 herds, so it's a bit harder to see. On the other hand, when we look at the human cases, there was a much nicer association between human cases and the wetness index. And all of this brings me to my discussion. So obviously we're having a poor vaccination compliance, so there's probably herds that are, despite not showing much lepto, but they're probably quite vulnerable. So if they would introduce lepto back in, there would probably be quite a nice pickup. Then we've kind of found possibly a correlation between this wetness index that we developed and the cases. And then the question is, how is it possible that herds that had lepto or human cases like 30 years ago are still herds that are associated with lepto now? So what's the reason for keeping lepto in these areas? So, and now this was the end of the presentation, and I'd like to thank my supervisors from uni, Dairy Australia, Soetis, obviously my participants, and everyone who helped put this project together. Thank you.